student. Today my new chapter is cubes and cube roots. Let's first discuss about cubes. Let me start it with the definition. The definition of the cube says that any number whose power is 3 is called a cube of that number. That means any number whose power is 3 is called a cube. You remember, any number whose power is 2 is known as a square. So similarly, any number whose power is 3 is called a cube of that number. Any number whose power is 3. Let's take an example. 2 into 2 into 2 can be written as 2 cube. 2 cube. Number with the power of 3 is known as a cube. So we pronounce it 2 cube. Similarly, it's a 4 cube and this is a 5 cube. So any number with the power of 3 is known as a cube. Let's take cubes of a natural number from 1 to 10. Cube of 1 is 1, 2 is 8, 3 is 27, 4 is 64, 5 is 125, 6 is 216, 7 is 343, 8 is 512, 9 is 729 and 10 is 1000. So from here we can say that cubes of natural numbers are called a cube number or perfect cube. So cubes of any natural number are called a cube number or perfect cube. How do you know whether a given number is a perfect cube or not? So for that, let's take an example. Let's take a number 243. So we'll do a prime factorization. We'll divide 243 by 3. I'll get 81. 81 will divide it by 3. I'll get 27. 27 will divide it by 3. I'll get 9. 9 is divided by 3. I'll get 3. 3 is divided by 1. So now 243 can be expressed as 3 into 3 into 3 into 3 into 3. Now we need to make a pair of 3 threes because we are finding a cube. So let's pair up. So now when I group 3 threes here, so I will see that these 2 threes are left unpaired. So this is not a cube. So from here we can say that since 2, 4, 3 cannot be expressed as the product of triplets of equal prime factors, so hence 243 is not a perfect cube. So from here we can say that 243 is not a perfect cube. There is a question in the question number 1. We need to find whether the given number is a perfect cube or not. We just check the question. So we need to do in this way. Please do not write this factorization on the rough color. Do it in the main part of the sum. Now let's take another example. 2744. Since it's even number, so it's divided by 2. I'll get 1372, which is also divided by 2. I'll get 686, which is also divided by 2. I'll get 343. 343 is divided by 7. I'll get 49. So now 7 ja 49, 7 1 ja 7. That means 2744 is equals to 2 into 2 into 2 into 7 into 7 into 7. Now we need to group 3 similar numbers together. So let's group it. Yeah. So 2 into 2 into 2 is the one group. 7 into 7 into 7 is another group. That means 2744 can be expressed as the product of triplets of equal prime factors. Hence 2744 is perfect cube. So now we got it. 2744 is a perfect cube. So if it is a perfect cube, the attached question will be there: find a number whose cube is the given number. So I need to find a number whose cube is 2744. 44. It's very easy. Already we got this one. 2744 is equals to 2 into 2 into 2 into 2 into 7 into 7 into 7. So I can write this as a 2 cube into 7 cube. So which is equals to 2 into 7 whole cube. So 2 7s are 14 cube. That means 2744 is a cube. Is a cube of 14. Is a cube of 14. So 2744 is a cube of 14. Please, my dear, look at the question. You need to do this question in this way. Please follow the instruction properly. My next question is find the smallest natural number by which 243 should be multiplied to make it a perfect cube. So 243. So as we know that how to factorize 243 because we have already done. So 243 can be written as 3 into 3 into 3 into 3 into 3. So we need to make a 3 similar number as 1. So 3 into 3 into 3 will repeat, but we will find that there are only 2 3's are there. So to make it a pair of 3, so I need to multiply 243 by 3. So hence the smallest natural number by which 243 should be multiplied to make it a perfect cube is 3. So if you multiply 243 by 3, so this number after multiplying with the 3 become a perfect cube. So we need to find the smallest natural number by which 243 should be multiplied to make it a perfect cube. So our required number is 3. Similarly, as I have told you, instead of multiplication, if division is there, so we need to multiply it by 3 3s are 9. 3 3s are 9 because I don't want it's 2 3. So keep this thing in mind. If it is a case of a multiplication, you need to multiply by 3. If it is a case of division, you need to divide it by 3 3s are 9. That means one-third number. Properties of cube numbers. Property 1. Look at this table. Here we have a natural number from 1 to 10 and their cubes are there. So cube of 1 is 1, 2 is 8, 7, 3 is 27, 4 is 64, 5 is 125, 6 is 216, 7 is 343, 8 is 512, 9 is 729, 10 is 1000. So from this table we can say that cubes of odd numbers are odd and of even numbers are even. So odd numbers 1, 3, 5, 7 and 9. So their cubes are also odd. Cube of 1 is 1, 327 is odd, 125 is odd number, 343 is the odd number, 729 is also an odd number. And the cube of even numbers are even. Cube of 2 is the even number, its cube 8 is also an even number. Similarly 4 is the even number, 64 is also an even number, like that. With 6 and 216 is even number, 8 and 512 is a even number, 10 and 1000 is a even number. Next property, look at this number properly. So from here we can say that if a number has 1, 4, 5, 6 or 9 in the unit place, if a number have 1, 4, 5, 6 and 9 at the unit place, then its cubes end with same digit 1, 4, 5, 6 or 9. So you can see that its cube will also end with the same digit 9, 9, 9, 9, 6, 6, 5, 5, 4, 4, 1, 1. Another, if a number has a 2 in the unit place, then its cube ends in 8. So if a number have a 2 in the unit place, the cubes ends with 8. Similarly, if a number has 8 in the unit place, then its cubes end with 2. If a number have 8 in the unit place, then its cubes end with 2. If a number has 3 in the unit place, then its cube ends with 7. If a number have 3 in the unit place, its cubes end with 7. If a number have 7 in its unit place, its cubes end with 3. If a number have a 0 in the unit place, its cubes end with 0. And keep in mind, there must be a 3 zeros. So now overall conclusion, if a number has a 1, 4, 5, 6 or 9 in the unit place, then its cube ends with same digit, that is 1, 4, 5, 6 or 9. If a number has a 2 in the unit place, then its cube ends with 8. 2, 8. If a number has 8 in the unit place, then its cubes end with 2. If a number has 3 in the unit place, then its cubes end in 7. If a number has 7 in the unit place, then its cube ends in 3. If a number has 0 in the unit place, then its cubes end in 0. Now question is this. From this property you will get one question. Look at the question down there. You need to do that question. It's whole questions on the basis of this property 2. The cubes of negative integers is always negative. The cubes of a negative integer is always negative. So keep this thing in your mind. If you have a negative number and you need to find a cube, of a negative number, then its answer is a negative. That means when you find the cubes of a negative number, you'll find the final answer is also negative. How come? Okay, minus 2 whole cube. Minus 2 whole cube means minus 2 into minus 2 into minus 2. So first sign multiplication, minus into minus, minus into minus is a plus, and this plus into this minus is equals to minus. So minus into minus is plus, plus into minus is minus. 2 to the 4, 4 to the 8. Let's take another example. Find the cube of 3 whole 1 by 5. So first mixed fraction will convert into improper fractions and we need to find a cube. So 16 by 5 whole cube can be written as 16 into 16 into 16 divided by 5 into 5 into 5. So 16 into 16 into 16 is 4096. 5 into 5 into 5 is 125. So when I divide this 2, I'll get 32 whole 96 by 125.